Vadim, nice to talk with you. I'm teaching C and C++ in my university. I took the source code in OpenCV as an example to the students, and I also suggested my students to learn C++ from OpenCV. I found the class Math is an excellent example, and I know you designed the class, so could you tell me some history of the class and why to design a new C++ class? I remember at the beginning, OpenCV used the RPL image and Sumat struct for images. So why you designed it? And can you introduce a little bit to us?
Yeah, sure. Yeah, glad to talk to you again, Shichi. First of all, I'm very pleased that OpenCV is now taught in universities, including your university, and you chose CVMAT as example of C++ design. Actually, it's a big pleasure for me and for the whole OpenCV team that our pieces of OpenCV design are used in such a way. Indeed, it took several years for OpenCV team to come up with this C++ class. In the very beginning, the very first structure in OpenCV, as you correctly pointed out, was IPL image. This is because OpenCV was started at Intel in 1998 as closed source library, then it was released open source. And at that time, at Intel, the family of so-called performance libraries, like for signal processing acceleration, for image processing acceleration, and like one of the libraries was IPL, image processing library by Intel, and it used IPL image as the main data structure. The original OpenCV was planned as addition to IPL, that is IPL will concentrate on image processing, and the OpenCV will concentrate on computer vision. And in the beginning, OpenCV was called CVL, Computer Vision Library, so it even used the same name pattern as IPL. Just instead of image processing, it used computer vision. And soon we realized that IPL image is not enough, because in computer vision, if you do, for example, camera calibration, some 3D vision, whatever, you need general matrix class. And sometimes for example, you need more than two-dimensional arrays, like three-dimensional array. Sometimes you need sparse multi-dimensional arrays. So in addition to IPL image, we also created CVMAT, CVMAT ND, and CVSparsMat to cover those use cases. Then, one time later, Intel abandoned IPL in favor of library of low-level primitives. It is called IPP, and it is still used in OpenCV for acceleration. And so, we didn't have to maintain compatibility with IPL since then, because the library was gone and replaced with IPP. So we mostly use CVMAT C structure for most of use cases, for point clouds, for matrices, for images, and but we constantly got requests from users to introduce C++ API, because C++ was much more convenient to use, instead of C. And in the year 2008, when Willow Garage company started to fund OpenCV. By the way, Willow Garage is the company who also created ROS, robotic operating system. So it was quite big startup at a certain point, and it funded OpenCV development. They gave us resources, and we started to think how to redesign OpenCV to use C++ API, and definitely we need C++ data structure. instead of CVMAT C and IPL image C structures. So we looked around and for the source of inspiration, and we found that MATLAB is very good example of good design.
Yeah.
That is, like, MATLAB is not as flexible language as C or C++, but it is super convenient. It has this matrix or array data type, and all the toolboxes in MATLAB use this data type. Therefore, there is absolutely no compatibility issues. Like, you just, if you want to use two toolboxes, you just download them and use together without like any wanting to convert data structures like from one type to another. You just use toolboxes together. And MathWorks even used those array data types for images. In MATLAB, there is image processing toolbox, and it also used matrix data type. And I really like this idea that one data type is used for any kind of array. And so we just tried to like replicate MATLAB API as close as we could. That is, we wanted memory to be managed automatically. We wanted convenient element access operations, etc. So we created this C++ structure, CVMAT, and it replaced all of the structures: IPL image, CVMAT, and D. SparseMat was a separate structure, but all the dense arrays were replaced with just a single structure.
We know different objects may share the same memory for metric data. To avoid memory leak, there is a complex mechanism in mat class. So if you redesign mat class now, will you use smart pointers in the new C++ standards?
Yeah. So indeed, shared pointer appeared in C++ 11, if I'm not mistaken, and in C++ 20. It was a special version of this shared pointer that can use atomic operations. And like, we created CVMAT in 2009, so even 2 years before C++ 11. So we couldn't wait for the new C++ standard to come out. So we used our own implementation of shared pointer. Of course, it's not a new idea. It was well known for like decades. Even Python created in 90s. It used like shared pointers with reference counting to manage memory, and it still uses this technique. So we wanted memory to be managed automatically, and we wanted memory to be managed in a thread-safe manner. So we wanted to use atomic operations from the very beginning, and we implemented this mechanism in CVMAT. And I would say that overall, CVMAT implementation and architecture is quite complex. If you look inside, you'll notice that, for example, there is not a single reference counter, but indeed there are two reference counters in each matrix. And so, like, overall, I would say if we use this modern C++ standard to implement like those reference counting and shared memory, I would say overall implementation would not become noticeably simpler. In other words, if we created CVMAT now, I would say the implementation would be almost the same as it was like many years ago. So even though like C++ standard go in the right direction, and for CVPTR class in OpenCV we use shared pointer. For matrix, I would say we would use the same implementation as before.
Mat class is not a template class. in my course, I asked my students to implement a matrix class to improve their programming skills. And I asked them that the matrix class they designed should support many different data types, including 8-bit integers, 16-bit integers, and the floating point, like that. So most students use the class template. So I think it's a very straightforward idea to use a template for that. So could you tell us why the math class you designed is not a template class?
Yeah, so we in OpenCV team we had some discussions like how to implement it, and at some point at Intel we had another project that implemented Bayesian networks, and like that was quite complex library, and they chose to go completely in template way. So they created everything in templates. And I know that like currently like heavy use of templates is one of like trends in C++. So many people prefer to use templates to get the best efficiency. In our case, we deliberately chose not to go completely in completely like template way because we saw bad examples when a library becomes unusable because of it's completely template, and so it takes very long time to compile code that uses those libraries. So like when we speak about like generic library of algorithms, like STL library with containers, basic like algorithms like sort, and so like it's not that much template code. There is still some, but it's not much. In the case of computer vision, algorithms are quite may become quite complex.
Yeah.
And so if you make matrix class a template, there is like strong strong motivation to put a lot of code into header files to make everything templates. And like for developers it may become like a simpler solution, but for users who use normally most of OpenCV users use just a tiny part of OpenCV, and for them like to wait those like long minutes or even hours for their code to recompile, it is a big problem. Unfortunately, together with templates in C++, they didn't introduce modules. Modules are coming to C++ only now, and even now the support for modules is immature. Maybe several years later, when modules become widespread, when compiling template code becomes much more efficient, then maybe more libraries will come out that will use templates. And now it's like not a good idea.
Okay.
So the first reason is we want to avoid long compile times.
Yeah.
The second reason is Python. So even like 10 years ago, we understood that Python has a great potential. It is excellent language, and besides there have been Java that we also want to support. And those languages, like Java has some support for templates, but it's like not completely compatible with C++. Python doesn't have any template, and we wanted OpenCV Python as well. So like if you have template library, then like creating wrappers for Python is quite complex task. Basically, you need to instate all those like functions in Python wrapper and like see what is the actual data type that the user for particular instance of template implementation. So it was not quite convenient. So I think we did it the right way, and we make right decision not to implement MAT or OpenCV in general as template library.
Okay, thank you. And yeah, I also learned a lot from it. Why? Because we always balance between many factors. So you introduced the factors in designing OpenCV. So, but I also found that there is a class template which is very similar to Mat in OpenCV. Its name is Mat underline. So since we have Mat class, why to design Mat underline? I mean the template. So you just explained the template have some maybe shortcomings and so, but we still find there's a template format.
Yes. So indeed, like there is another class that is like have this underline or underscore in the end of the name, and it doesn't introduce any new members, so it's binary compatible with normal CVMAT in both ways. So it use and it derives from MAT. So you can basically use it instead of MAT. And the only reason was to provide convenient element access operations. Like if you have, for example, if you have some matrix algorithm that operates on floats, it is like first option to access an element, you use template add method with unbuilt brackets. So you just say like my matrix dot add in angle brackets. You put data type like float, and then you put indices say in the parentheses. And with mat underscore, you just use parentheses. You don't need this add with angle brackets. So it's a notation. But I would say that the number of such algorithms that access elements directly in this way, some like savings that you have by like typing less symbols, it is so small that I would say that if we design matrix class today again, I would not create this extra template class because like most people just use normal CVMAT.
Yeah. Okay, and so I have another question. The question maybe is about hardware because currently there are many kinds of hardware. Than in the past. In the past, maybe only CPU or mostly CPU. Currently, we have GPU, NPU, or VPU. That means so most of them have separate memory. So is it possible to design a universal mat class which can handle different kinds of memories?
Right. Yeah. So indeed, nowadays, like using GPU or specialized accelerators to speed up computer vision is very popular trend. Like everybody goes in this direction. Like for example, NVIDIA Tegra is used in cars, for example, and such. So it's indeed very popular. Unfortunately, from software side, there is no good standard to like program those hardware in a universal way. About 10 years ago, when we had projects with AMD and Intel to bring OpenCL support into OpenCV, I thought that OpenCL will soon become like such a universal standard that everybody will use OpenCL to program that hardware, such a hardware like GPU or like specialized computer vision accelerators. And so for OpenCL in OpenCV, we created special class called UMAT that people can use like to access OpenCL functionality. And also OpenCV included several hundreds of OpenCL kernels to accelerate various algorithms from image processing to machine learning and such. Unfortunately, like now OpenCL is sort of like semi-abandoned standard. It's still the development and new work come out, but it looks like most manufacturers try to use something else, like Apple uses Metal, then on Android Vulkan is like more popular for games, for example. Also, like there are like some like emerging standards. For example, there is standard called OpenACC, Open Accelerator. It all like aims to bring some extensions to C++ standard to offload some loops to GPU. But it is not quite mature. So I would say we're still waiting for such a standard come out to conveniently program various hardware. Actually, currently there are some like positive trends. For example, Vulkan group in Kronos committee and the OpenCL group, they work together, make like to provide OpenCL compatibility for Vulkan-based hardware and such. So maybe OpenCL is not completely dead, and it will maybe revive at some point. So we are still waiting. Without that standard, it is difficult to come up with such a universal class because you do not know which API to rely on because everybody uses different API.
Yeah, and I have still another question. Actually it's two questions. The first question is, does OpenCV have any plan to update Mat class to a newer one, or we will continue to use the current one?
Yeah, so OpenCV is quite mature library with many users, and so like there are no plans to completely replace CVMAT with something else. And CVMAT is quite flexible. For example, for Python bindings, users do not see this CVMAT class. They operate on like common on very popular in Python world NumPy arrays.
Yeah.
And internally, those NumPy arrays are converted to CVMAT. Usually, it happens without copying any data, so it's very efficient. We try to use these zero copy techniques. Internally, we do not, as I said, we do not plan to completely replace CVMAT with something like completely new, but we want to make some upgrades to CVMAT. Like first of all, we plan to extend the number of data types supported. So maybe it will be some new integer data types. Also, we plan to add bfloat 16, so brain float 16. This is the relatively new floating point format developed by Google and used in their GPU accelerators, and also it is now supported by Intel hardware, upcoming ARM v9 and some other architectures. So it's quite popular, and we want to add support for it. Like another new feature is to support one-dimensional arrays. We, as I said, we borrowed this CVMAT class idea from MATLAB, and in MATLAB there is no one-dimensional array. As far as I know, one-dimensional array is represented as two-dimensional 1 by n or n by 1 array.
Yeah.
And so in OpenCV we took the same convention. But it appears to be not quite convenient for Python bindings and for some deep learning areas that we are trying to add to OpenCV currently, like speech recognition or whatever. So in some areas, one-dimensional arrays are important, and we want to add support for real one-dimensional arrays into OpenCV. The third feature, we are still thinking of it, but maybe we'll add some tag into math that will indicate, that will provide some indication what is the data that math stores. For example, the tag can be RGB or BGR to indicate what is the order of channels. And maybe it will solve some old problems when people just use some matrix with incorrect data channels, and sometimes they get wrong visualization, like instead of like a red face, you get blue faces, like an avatar. In some cases, you just get maybe slightly worse performance from some deep net object detection networks. So it still detects objects, but not as good as with proper order of channels. So it's very subtle bug to detect. And maybe with these tags, this problem will disappear. So we are still thinking of.
Sure. Yeah, because in my course, the final project is to do some CNN. They should implement CNN by themselves. So in the data reading from my image, the default channel is the BGR. So a lot of students were confused by that and made some errors. So I know there will be some students from my class and also from maybe all over the world will watch this video. Do you have any suggestions for the students in computer science, especially the students who are learning C++?
Okay. I think that currently there are like many sources of information. There are many good online courses on computer vision, and I'm glad that you are teaching this C++ class. I saw some bits of it, and I think it's very professional. So I think I'm sure that students will learn a lot from it. So maybe I add just a few common words. So like feel free to ignore them completely. Just from my experience of developing software for like quite a few years, I would suggest students to pay more attention to like algorithms, concepts, technologies, rather than particular feature of particular programming language. So like many years ago, like Fortran was the most popular language for computing. Then C became the dominant language. Then C++. I would say currently maybe Python is used more, especially with special acceleration extensions like NumPy or whatever, or Cython. Maybe Python is used more actively for computing than everything else. So do not pay too much attention to the particular feature of particular language, and do not try to use all those fancy features of the language that you just learned in your project, because those features just exist, and you want to like make your code look cool by using all those new features, because like there's a big chance that a couple of months later you wouldn't be able to read your own code because it's like too complex.
I think this suggestion is especially for C++, right? Because there are too many features in C++.
Yes. C++, I would say it in the recent standards they made some things more convenient to use, like modules. It is a very important feature, I believe. But on the other hand, the language is becoming quite more and more complex, and so like you need to like develop proper style of using C++, not to shoot yourself in the foot. and like try not to use manual memory allocation. Use existing containers like std vector, or if you use OpenCV, use cvmat, etc. Like try to like put some regression tests before you do any refactoring or optimization. Like there should be some tests, of course. So like, yeah, as I said, develop some methodology, proper methodology, how to create robust software that is easy to debug or doesn't need to be debugged at all. It works out of the box. Instead of just using very complex language constructions that you may not fully understand.
Yeah, sure. Yeah, I also found a lot of students they spend a lot of time on debugging, and it's take them a lot of time to find a very tiny bug. It's very difficult in C and C++ because there are memory leaks and maybe some pointers has invalid values, so it's quite common.
Yes. So like automatic classes you mentioned, for example, shared pointer, it is another very good tool. Like when people like avoid using raw pointers in C++, but instead use containers like std vector or cvmat or shared pointers, like the number of memory related problems like goes almost to zero.
Yeah. Thank you for the suggestions.
Yeah, you're welcome.
Yeah. I believe the students will be benefited from your suggestions and also your introduction to OpenCV. Okay, thank you.
Yeah, you're welcome. You're welcome.